All right, so far so good. Here's another example for us to talk through this time. We got an IQ test, and it's supposed to have a mean of 100 and a standard deviation of 15. That's what it's supposed to do. And let's say we survey 20 people at random. We do a good survey. It's random sample, no leading questions, all those IQ tests or whatever. And we find a mean of our sample of 95. So is that okay? Did we do it right? And we'll do a check here. We'll do a little test with a 90% confidence level. So that's what we're shooting for here. So let's work backward a little bit here once again. I know standard deviation for the population, right? I know it for the whole test. The whole test is supposed to have a mean of 100, and it's supposed to have a standard deviation of 15. So we'll use that population standard deviation, which means I get to use this other equation for my margin of error. I'm still going to try and produce the confidence interval based on my sample mean plus or minus my margin of error. And hopefully 100 is somewhere in that interval. That's what I'm shooting for. So once again, I'm going to get my critical value. But remember, since I've got my population parameter, I am using the z-based, the z-score here. So 90% confidence level, the critical value for the z-test is 1.645. So that's my critical value there. And that pops into the equation. I've got critical value, standard deviation, root n, and all that comes out to be about 5.5. So I know my margin of error is 5.5, which means my confidence interval is 5.5 up or down from my sample mean. So I add 5.5 to my sample mean, I have 100.5. I've got 89.5, that's the subtraction of 5.5, that's my lower bound. So I know that my mu value, sorry about that typo, mu is somewhere between 89.5 and 100.5. And hey, 100 is on this interval. So I have, for my 90% confidence, the 100 value that I want on there. So we're good, right? The fact that it's not centered at 100 doesn't change the fact that it's on that interval. So hey, working as intended. Nothing terribly awry here. If it had been from 89.5 to 99.5, I might be a little alarmed. Of course, I can still write off to few samples or something like that, but that is acceptable because we are at 100.5. And that's the example start to finish. So really, as far as number crunching is concerned, if you have this table, it's pretty quick to get whatever critical value you need. And also, as long as you have standard deviation of some flavor and a sample mean, then it's not too hard to crunch the numbers. So let's talk about this example. What if you aren't given sample mean and you have to find it? What if you aren't given sample standard deviation and you have to find it? What do you do then? So I want to read this example to you here, and we will get deep into the paint on this one in the next video. If you feel like you want the time to review, maybe in between this video and the next, just see if you cannot figure out what is the mean of this sample and what is the standard deviation of this sample. But I digress. I want to talk about the magic 4-year degree, the bachelor's degree, that's offered by what's called 4-year institutions. And it's called that because it takes a full-time student at least 4 years to get. Some finish sooner, not many. Most take at least 4 years to get. And so I want to know, what is the average completion time or the mean completion time for a student getting a 4-year degree? I got 20 samples, they're random, and I've got 6 students out of 20 taking exactly 4 years. 3 of them take 4.5 years, 2 take 5, and more and more and more. So what is the mean graduation time for graduating seniors for this sample, or for the whole population rather, using this sample? So we'll get into this in the next video, but before then, try and find for me the sample mean and the sample standard deviation. And I'll see if you're right in the next video.